Okay, so last conic section we're going to look at is the hyperbola. So the hyperbola, we're going to start with the definition. I'll show you a picture, and then we'll go through all the vocabulary for a hyperbola. So hyperbola, first of all, it's a collection of points in the plane that's how every conic section definition starts. A collection of points in the plane, and then there's a condition that it meets. So for an ellipse, it was a collection of points in the plane such that if you measure the distance to two fixed points, it adds up to a constant. We change one word in that definition, and it's a hyperbola. We're still going to measure the distance to two fixed points, and that distance is still going to be a constant, but it's not going to be the sum of those two distances, it's the difference. Okay? So changing that one word in red from sum to difference, that changes the definition from an ellipse to a hyperbola. And I'll show you a picture, but you pick a point anywhere on the hyperbola, measure the distance from that point to two fixed points. Take those two distances and subtract them, and you will always get the same number. What number you get, that's not really important. It depends on what kind of hyperbola you draw, but for a certain hyperbola, it will always come out to the same number. Okay, let's look at a picture. So there's a hyperbola. It's one of two ways you can draw a hyperbola. This one opens left and right. They can also open up and down. So I could kind of turn this 90 degrees. All right, so E. That's a point that I can drag anywhere on purple curves. The distance from E to C and the distance from E to B is going to change. But if you subtract the two numbers, it's always going to come out to 5.66 in this hyperbola. So let me drag it, put it down there, and let's check it. Let's subtract them. So now I've got 11.07 minus 5.41, 5.66. It'll always come out to that. Even if I go over to the other part over here. No matter where you put it, if you take those two numbers, subtract them, the distance is always 5.66. If that's true, then you have a hyperbola. That's what makes a shape a hyperbola. Okay. Now, yesterday, these two fixed points, they had a special name. Does anybody remember what we called the two fixed points yesterday in an ellipse? What, Jake? The foci, yes. They're exactly the same name today. So in my picture, C and B are the foci. If I was labeling a diagram, I'd probably just call them F1, F2. Foci 1, foci 2. Now, yesterday, the line that went through the foci, what did we name that in an ellipse? It goes through the foci and it goes through the vertices.
Major axis?
It was called the major axis. It's not called that today. Okay. It's the same idea, it just has a different name. It's called the transverse axis. And the way I remember what it's called, because we had major and minor axis yesterday, we're going to have transverse axis and something else. The way I remember which one is which is when I look at transverse, to me that kind of looks like the word traverse. Right? And if you traverse something, what does that mean? Go across. Like if I said, okay, we're going to traverse that canyon. We're going to go from one side to the other. Well, the transverse axis goes from one side to the other. Goes from one of the purple curves and it connects over to the other one. Think of it as like a bridge. Right? It connects one side to the other. It traverses. Transverse. So transverse axis is taking the place of the major axis. Now, if I found the midpoint of the segment that connected the foci, okay, like this. Here's a focus, here's a focus. Draw in that line segment and find the midpoint. What do you think that point's called? The center. It's exactly the same definition we had yesterday. There's no change in that from what you wrote yesterday. The midpoint of the segment connecting the foci is called the center. Now, with an ellipse, if I drew a line perpendicular to the major axis through the center, what axis was that? The minor axis. Okay. Well, if I draw a line through the center, perpendicular to the transverse axis, it's called the conjugate axis. Okay, so the names transverse and conjugate are taking the place of major and minor. Same concept, different name. Now, those two parts of the hyperbola. Hyperbolas always have two parts, either like this and like this, or like that and like that. We're never going to be drawing them on like an angle. Okay? They either open up and down, or like the one I showed you earlier, left and right. They're not called parts, they're called branches. Okay? The two branches of the hyperbola. And if you draw in the major axis like that, it hits the hyperbola there and there. Or if you put your major axis in, it hits it here and here. Does anyone have a guess what those two things are called? It's a name we used it yesterday. Those are your vertices. So the point where the transverse axis hits the hyperbola, those are your vertices. Yesterday, the way we said it, the point where your major axis hits your ellipse, those are your vertices. So it's the same definition, it's just using the words from today instead of yesterday. Okay, so a lot of vocab kind of up front, but then after that we'll do more calculations. And the feel of the calculations today, it's going to be exactly like yesterday. You're going to be finding an A, a B, and a C, and an H and a K. The H is going to mean the same thing, the K is going to mean the same thing, the A is going to mean the same thing, and the C is going to mean the same thing. So it's going to be very, very, very similar. Which is good because it doesn't really require you to understand like a totally new idea, but it's bad because it's so similar that it can be confusing. So you got to try to remember which one is which. Or make a good reference sheet. Okay, so first kind of hyperbola we're going to look at, center is at the origin. What happens when it's not at the origin? Well, you're going to have an H and a K. We'll look at that after. The foci are going to be C units away from the center. It's exactly what we had yesterday. And this is going to be the case where the foci are to the left and to the right. Okay? That's a big difference. How do you figure out if things are left and right or up and down? Yesterday the trick was to look where the bigger number in the denominator was. That doesn't work anymore. There's another trick. It's just as simple, but you got to remember what the trick is. Okay? Your vertices are going to be A units left, A units right. So again, this is the case where everything is going to be horizontal, left and right. Okay, so here is your equation. If you look at that equation, what's the difference between that equation and the one for an ellipse? One thing. Yeah?
It has a subtraction to the addition.
That's the only difference right there. Very small difference, but huge difference when you draw the picture. An ellipse and a hyperbola don't look anything alike. Okay, so put a minus between the two. Now you've got a hyperbola. It's still equal to 1. You still have x squared, still have y squared, you still have a squared and b squared. Now, yesterday, the connection between a, b, and c was c squared equals a squared minus b squared. Today it's plus b squared. Now, I didn't write down a is bigger than b, and b is always bigger than 0. Because a is not always bigger than b today. The way you can tell where a always goes first. Think of it alphabetical. A squared is always the first denominator. That never moves, ever. Always put a squared as the first denominator. Always put b squared as the second denominator. So, if the a and the b aren't going to move, well, something has to be moving because there's going to be a case when it's horizontal and a case when it's vertical. It's the x and the y. Okay. Today, the x and the y are what switch places. And this is how you tell whether it's horizontal or vertical. Look at the x. It's positive. Look at the y. It has a negative in front of it. Whichever letter is positive, that's the direction of the transverse axis. So the x is positive, x is the horizontal. If I were to switch the x and the y, I'll show you, and I'm going to give you time to write it down after. But now I've switched the x and the y. Now the x has a negative. The y is the positive. Since y is positive, y goes up and down. That's vertical. Okay. So today the trick is look for the positive letter. Not the bigger number. Look for the positive letter, x or y. Now, when I draw my hyperbola, I'm going to have something like that. The sketch can be a little tricky. So what we figure out is this. Basically figure out an x shape. And once we know that x shape, the hyperbola branches are trapped in that part of the x shape. Does anyone remember what we call those dotted lines that something gets like closer and closer and closer to? It's an asymptote. So hyperbolas have 2 asymptotes. And the way you figure out what the asymptotes are is that formula right there. Y equals positive b over ax, negative b over ax. So you don't have to find a new letter. You're still finding a, b, and c, just like always. You're just using a and b for something extra now. Okay? We're also going to use them to find the slope. Now, in this case, it's b over a. When we do the next case, it's a over b. It flips. So how can you remember which way is which? Well, I'll show you how I remember. When it's horizontal, and this one doesn't really help as much, but the next one does. When it's horizontal, it's b over a. When it's vertical, it's a over b. So I remember VAB. Right? VAB. Vertical, the slope would be a over b. Horizontal, well, haba. That doesn't really mean anything to me. But VAB, I just remember VAB. Vertical, a over b. So the other one must be b over a. Horizontal is b over a. We're not going to worry about that. Okay. What is important are this part. Don't worry about this. Because when we graph it, we're going to have those asymptotes. So that's going to be good enough to graph it. But A is still going to be the distance from the center to the vertex. C is still going to be the distance from the center to the focus. The fact that the book puts an absolute value around that A, I don't even think it really is going to make a difference. I wouldn't even worry about the absolute value. It's the way we're doing it, it's going to be fine. So A is the distance from the center to the vertex. C is the distance from the center to the focus. What doesn't really have a visual meaning today is B. B, we could visualize the distance from the center to the minor axis. As far as I know, B has no visual connection with this picture. Okay, just A and C. But that's fine, because you've got a formula to find B right there. Okay. Right, so the kind of questions are going to be exactly the same as yesterday. I'll give you some information and tell me the equation, or I'll give you the equation and you tell me some information about it. Okay, regardless of the kind of problem you're doing, whether it's you give the equation or I give the equation, you still want to find A, B, C first. And eventually H and K. But you don't have to worry about H and K in this one, because it's 0, 0. Okay, so let's start with A. Same meaning as yesterday. So what's A going to be?
The distance from the center to the vertex.
Yep, center to vertex. So in this problem?
-2. Just 2.
2. Yep. So the reason we're not going to put the absolute value is because when I write down the word distance, distance means absolute value. You can't have negative distance. Right, so if you think of it that way, then you're good. So A, B, don't have enough information. How about C? 3, distance from center to focus. Now, be careful with this one. What's the formula that connects A, B, and C for a hyperbola? Yeah?
C squared equals A squared plus B squared.
Yes. If you accidentally do A squared minus B squared, it's wrong. Okay, you can't use that one today. So C squared, A squared, B squared. So 5 equals B squared, and technically that's all you need. Because B squared is what you're going to put in the denominator. If you really want to know B, it's the square root of 5. But we don't need it. Okay, so let's set up our equation. Bless you. Okay, hyperbola, if you looked at the formula, it's always equal to what number? 1, same as yesterday. What are you going to put between the two fractions? Plus or minus? Minus. Now, what letter squared always goes in the first denominator? Never changes. A squared. Second denominator? B squared. I got it right there, 5. Now what we have to think about a little bit, bless you, thank you, is where we put X and Y. Graph the focus and the vertex. See how they line up. There's a focus. There's also another focus at -3, 0, but you don't need it. There's a vertex. How do those points line up? So which way? We have 2 options. Horizontal. What letter is associated with the horizontal? X. So we want to make sure when we put the X in our formula that it's what? Doesn't have to do with being above the bigger or smaller number. If that happens, it's just a coincidence. But we have to make sure that the X is first because it'll be positive, right? Technically, you could put it second if you rewrote it in kind of a funny way, but the point is, however you do it, make the X positive. How do I do it? That means it's usually first. That's how I write it. X squared, y squared. And that is your hyperbola. Any questions on the equation? Okay, I'll graph this one. I'm not going to keep graphing all of them, but I'll just show you how to do one. Now, there's one other piece of information I need to graph.
Yeah.
What's the other thing that's going to help me graph it?
The asymptote.
The asymptotes. When everything is horizontal, what did I say the slope was for the asymptotes? Horizontal is
B over A.
B over A. So B, I guess technically I do need B. B over A. Rise over run. So square root of 5 over 2. Positive and negative. Now, since I need to graph that, I need to know what the square root of 5 is. It's about 2.2. That's accurate enough because I can't graph it any more accurately than that. So the top is about 2.2. Okay, so that means I'm going to go, actually I already have it, but I'll just do it again. I'm going to go up 2.2, that's my rise, and then my run is 2. Right, so make it bigger so you can see it. But I went up a little bit more than 2, right 2. Then I went up a little bit more than 2 again, right 2. And then I did the same thing. Down 2.2, right 2. Down 2.2, right 2. And I did it a couple times. Okay. Once you get your points, put in your line, and it's close enough. They should go right through the center. Pretty close. It's close enough. All right. Now, draw your branches, and just make sure you stay inside the X shape, okay? Remember, it's horizontal, okay? So they're going to open. One other thing we should do, let's graph the vertices. Because that's going to be a point that they go right through. So it's going to go kind of like that. Get closer and closer and closer. And same thing here. I didn't draw it perfect, but you get the idea. If you want to see what it would look like without the asymptotes, just move them off for a second. But there's the two branches of the hyperbola. When you sketch it, you can just leave the dotted lines. You don't have to erase those. Okay. Any questions on the sketch? So if you plot your two vertices, you'll know what part of the X shape you're in, right? Either left, right, or top and bottom. Right, let's look at this one. This one, just discuss. So I don't want to see a graph. And there's 5 things you need to find. Okay. 4 of them are the same as yesterday. This is the extra. Asymptotes. Okay, so to do all that discussing, we're going to find A, B, and C first. So how about Morgan? Out of the A, B, and C, you see one of those I could figure out? C is the only one we can't. We can't do C yet. We're going to do C, but we need A and B first. Okay, what number there tells you something about A? Jake? The 16 is A squared. Remember, the first number is always A squared. The second number is always B squared. A squared, B squared. So Jake, if the first number is A squared, then A must be 4. If the second number is B squared, then think back, what must be? Come on, 2. Now we can get C. The only reason I need C is to do this right here. If they didn't ask me for the foci, I could do the vertices, the center. I could do everything without C, except the foci. Devin, what's the formula for finding C?
Was
Yep.
C squared equals A squared plus B squared.
C squared equals A squared plus B squared. So C is the square root of 20. If you broke that down, how would they write square root of 20 simplified? 2 square roots of what? Yeah, 2 square roots of 5. You did that almost as fast as I did in my head. Nice job. 2 square roots of 5. All right. This is not the order I would do it in. I start with the center, and then I do the transverse axis. So that's how I'm going to do it. Where's my center? Yeah, it's 0, 0. You'll know when it's not 0, 0 because you're going to see like x minus something or y minus something. Okay, so the center is 0, 0. Transverse axis goes which way? Horizontal or vertical?
horizontal.
Horizontal because x is over the bigger number. Is that why?
No, it's because X is first, which is
Yes, it's because x is positive, right? So transverse axis is horizontal. That tells me that everything is now left and right of the center, horizontal. So my vertices are 4 units left and right of the center. There you go. 4 units left, 4 units right. What letter here tells me about the foci? We just did that one. C. My foci are 2 root 5 units left and right of the center. And my asymptotes. You just got to remember when the transverse axis is horizontal, my slope is what? B over A. 2 over 4. And if you can reduce that, we should reduce it. So 2 over 4 reduces down to positive or negative 1/2. So if we had to graph it, that would actually be an easier one to graph because the rise and the run are nice numbers, not square root of 5 or something like that. Okay, so any questions on how we found those 5 things?
How did you find the transverse axis again?
Transverse axis, because the x is positive.
Okay.
Either the x is going to be the positive or the y will be. Whichever one is positive, that's the direction of the transverse axis. All right, this is another discuss. I don't think we have to go through the whole thing, but let's just go through what the first step would be, because it's different than the last one. What would be your first step to discuss this? Yeah, divide everything by 36. And then you would have x squared over 9 goes into 36. How many times? 4. They usually set these things up so you don't get decimals. So 4. 4 goes into 36. 9 and 36 goes into 36 once. Now you're ready to discuss it. It's equal to 1, just like the last problem. So we just go from there. Any questions on how you do ABC from here? It's exactly the same as the last one. Okay, so that's the only extra step in this one. Do divide by 36 first. Okay, so now this is the other case of the hyperbola where everything is up and down. So C units below and above for the foci, A units below and above for the vertices. The center is still 0, 0. That's the same. C squared equals A squared plus B squared. That's the same. Now, I already showed you, but does anyone remember what the slope was when it was vertical? A over B, fab. Vertical was A over B. So now we'll do exactly the same thing we just did. We'll do one where I give you the equation. We'll do one where you give me the equation. Like I said, like 20 times now. Whichever way you're doing it, find A, B, C, H, and K first. Well, technically H and K don't matter yet, but they will. Okay. So, only difference between this equation and the last one, look at the x and the y. They switched. Y is positive. X now has a negative in front. Any questions on that stuff? Okay, let's look at an example. So discuss. Actually, this is kind of like the last discuss. What's the first thing you'd have to do here? Yep, let's just divide everything by 4. So I'm just going to change it. Divide by 4. If you divide that by 4, it would become a 1. And if you divide that by 4, it would become a 1. Okay. So Isaac, what is a here? Careful, that's a squared. 2. A is 2. And Isabel, how about B? 1. Okay. Not because there's a 1 here, but because the square root of 1 is 1. And then C squared equals A squared plus B squared. So A squared is 4, B squared is 1. 4 plus 1 gives me 5. So C is the square root of 5. Okay, so that's all the important stuff you need. Now you can do whatever you need to do. Okay, I'm going to start with the center. Where's my center? Yep, you'll know when it's not. Which way does my transverse axis go? Vertical, because y is the positive. So now I know everything else is above and below the center. Okay. How far away are my vertices from the center? 2. 2 units up, 2 units down. How far away are my foci from the center? Square root of 5 up, square root of 5 down. And my asymptotes, I'm just going to remember the slope. B over A or A over B? For vertical, A over B. What was A? So it's 2 over 1. You can just really write 2. So those are all the things you could possibly be asked for. And you might not be asked for all 5. Maybe on the test I'd just say, tell me the vertices and the foci. Okay? But whichever ones I asked you for, that's it. I couldn't ask you for anything else. Okay. Questions on that? All right. So I gave you the equation. You tell me the equation. And then we'll finish up with what happens when it's not at the center. Okay. First thing you have to do always is what? Before you even set up an equation.
Find A, B, and C.
Find A, B, and C. Yep. Bless you. Okay. How about Sam? What is A going to be in this case?
It would be 2.
Yep. A is 2. B, you never have enough information to find B directly, ever. Unless it's an ellipse. You can sometimes. But you always really find A and C. Okay. C is center to focus. So what's C?
3.
3. C squared equals A squared minus B squared. So B is going to be the square root of what number?
Plus B squared.
Yes, just making sure you're paying attention. Actually, I made a mistake. Yes, it's the square root of 5. So minus the 4, you get 5 equals b squared. So b is the square root of 5. All right, now we can set up our equation. Equal to what number? 1. Plus sign or minus sign between them? Minus. First denominator is going to be a squared. Second denominator? B squared. Now we just have to decide where the x and the y go. If you're not sure, I mean, some people can just kind of visualize that in your head, but if you're not sure, you've got a vertex up there, you've got a foci up there, and another foci down there. They're all lining up vertical. So, which letter should be positive? Y. Y. Y squared, x squared. Bingo. And that's your equation. Any questions on that? Okay, so we did one where you found the equation. We did one where I gave you the equation. I don't think we need to do another where I give you the equation. All right. So this is all in your packet. So I would not write all this down. In fact, when I think of it, I don't even think of this. It's not wrong. It's right, but I don't even think about that. I don't even think about that, or that. Okay? Don't cross them out, because maybe you want to think of it that way. I just think of it as A is the distance from the center to the vertex. C is the distance from the center to the focus. Okay? Is it up, down, left, or right? I don't know. I figure that out once I figure out which direction the major transverse axis goes. This is what's important. This and that. This is the equation when the hyperbola is shifted. Okay? So if you can't read or anything didn't copy clear, you might want to just copy it, and if you can read it, fine. Good. A squared is always the first, B squared is always the second. Doesn't change. Both of them always equal to 1. Doesn't change. X minus h, y minus k. It's just like it was with an ellipse. X and h are a package deal. They go together. Y and k, they're packaged. They go together. Okay. H comma k is the center. Let me just zoom out. I guess it went off the screen. But you have it in your packet. H comma k is the center, and that is how I think of it. To me, that's important. So the column that has the center and the equation, those are the only two things that I really think about. What else is here? Now, look at this. Is that what I told you the relationship was? What did I tell you? C squared equals A squared plus B squared. Oh, isn't that the same thing? Really?
Yeah.
All they did was take and subtract that and put it over there. A squared or C squared minus A squared. I mean, you can do that, but to me, I already know the Pythagorean theorem, so it's just easier for me to remember it in that order. So I don't really think of this that way. And this is the equation for the asymptote. Okay, at first, that looks kind of weird. Well, I still have the b over a and the a over b. That part's the same. But the rest of that, I think of it this way. Y minus y1 equals m times x minus x1. What did I just write down?
Y.
That has a name. It's not y equals mx plus b. That's called slope-intercept. What is this called? No, not midpoint. Midpoint usually has like a divide by 2 in there. Well, looking at that equation, what's in it? Okay, and a y and an x, what does that make up? If you just have an x and a y value, it's just it's a point. And what else is in that equation? The slope, m. So what do you think we call that equation?
Point slope.
It's point slope. Algebra 1, point slope. I normally don't use point slope. I like what slope intercept, y equals mx plus b. But point slope works perfect if you have a point and a slope. Well, what's the slope your asymptote is going to have? We already did that. It's the a over b or the b over a. Depends. What's the point it's going to go through? Well, if you have two asymptotes, they both go right through the what? They could go through the origin if this point is at the origin, but they go through the center. Wherever the center is, your asymptotes go through the center. So you automatically have a point that your asymptotes go through. It's the center. And you automatically have the slope from what we did before. Okay? So even though they write all this stuff here, y minus k and all that, I don't even think of that. I just think of point slope form. I mean, it's really the same thing. I just think of point slope because I remember that from Algebra 1. All right. So I was going to leave that up there, but you can't really see it. It's kind of small. But I'll leave it anyway. If you need it, just look at your packet. Okay. So find the equation of the hyperbola. So now we got all 5 letters we need to find. Out of those 5, you're going to be able to find 4 without doing any work on paper. Okay. Can someone give me one of the letters?
H is 1.
H is 1. Yep, I agree. How about another letter?
K is -2.
K is -2. As far as extra work, you're done. That was the 2 extra things you had to find. Now, how about A? Distance from center to vertex. 2. These numbers don't matter. They're all -2. So to find the distance, just look at the ones that are different. Center is 1, vertex is 3. Okay. Center is 1, focus is 4. How far apart are 1 and 4? 3. So the distance from the center to the focus is 3. But I'm missing one of the letters that I really need. I've got to have B. I've got to have B. Okay. So what's the formula to find B?
Square root.
C squared equals A squared
plus
plus B squared.
Well, we've done it for the last 5 problems.
Yeah, these numbers keep coming up. It's the same thing we've done over and over. What did B come out to?
Square root of 5.
It's the square root of 5. It's not always going to be the square root of 5, but I am always going to pick numbers that come out pretty nice. You're not going to have numbers like in the thousands or something like that. They're going to be like pretty small. Okay, let's set up our equation. 2 fractions equal to what number? 1. Between the fractions? Minus. First denominator? A squared. Second denominator?
B squared.
B squared. All right. Now we got to think a little bit about what goes here and what goes here. Something squared and something squared. Look at all these points. They all have a y value of -2. If that doesn't mean anything to you, then draw it. Right 1, down 2. Right 4, down 2. Right 3, down 2. They're all down 2. So they all line up what way? Horizontal. What letter is the horizontal? X. So we want the X to be positive. X here, Y here. Now the H and the K, it's a package deal. What letter always goes with X? Minus H. So X minus H. Now, with the Y, be careful. It's Y minus what letter?
-2.
K. But look at K. What happens when I do Y minus K? plus. And that's the equation of your hyperbola. Okay. Any questions on that? Okay, so that finishes up conics. You don't need the. You might want to hang on to the packet for the final. There might be a couple practice problems I have you do from there. Also, I have the review for the final ready. I'll probably give it to you this week. I'll give it to you before the weekend. Okay, so homework, similar to last night. You got 13 to 16, so that's all. And then the rest is odds. 17 to 21 odd, 29, 31, and 37 to 41 odd. Okay, don't forget, we're going to have our test on Thursday. So, if you're not here tomorrow, I guess there's a plague or something? It's crazy. But I think I'm immune. I've been here 12 years, so I'm good. Got a robust immune system. You might want to check the video and make sure you're good for the test on Thursday, because you won't have time to take it on Friday if you're being dismissed for a couple.